love our cars, but not the pollution they produce. In the UK, transport accounts for a third of CO2 emissions. Electric vehicles are seen as key to solving that, and by 2030, the European Union needs at least 30 million electric vehicles, or EVs, to reach climate targets. But the efficient recycling of the lithium-ion batteries they run on is still being sorted out, and we need to make sure we're not replacing one sort of pollution with another. I'm here at the University of Birmingham, where researchers, along with their colleagues at Leicester, have discovered a new method of separating and recovering materials. Dr. Dan Reid is the head of the Relib team at Birmingham University. Relib stands for the recycling and reuse of EV lithium-ion batteries. Birmingham is one of 5 universities involved in the project.
We've been involved in this project for the last 3 years as part of the Faraday Institution, and we're making huge progress.
It's an initiative to develop alternative, greener, more efficient recycling routes to extract the valuable materials. One of the problems is everybody is making their own type of EV battery, and there's no standardised approach to recycling.
So working on all electric vehicles and some of the hybrid vehicles that use lithium-ion batteries, so we're trying to recycle all possible lithium-ion batteries that are on the market at the moment.
Is it just recycling you're working on, or is it bigger than that?
So we want to keep the materials that are in batteries in the economy and within the life stream process. So once we've got the materials and they're being used, we don't want to put them in landfill and get rid of them because they're valuable materials. Some of them are critical materials that it's very difficult to get hold of.
Like me, you might be wondering why the manufacturers didn't figure out the recycling part earlier.
So the evolution has to happen at some point. Something has to start and something has to catch up. And if we waited to get a recycling industry set up and ready to go, they wouldn't have anything to recycle anyway until cars come to an end of life. So we needed to get the cars in the market, we needed to allow the technology to mature, and we allow the recycling industry to mature and keep with it. So as the recycling industry can only survive if there's something to recycle.
The term lithium battery refers to a family of different lithium metal chemistries. A lithium-ion battery is rechargeable and is used in EVs. Typically, it has an anode made of graphite coated on copper foil. Plastic separates it from the cathode materials that are made of layered crystals of lithium metal oxides, which are usually a mix of nickel, cobalt, aluminium and manganese coated onto aluminium foil. Lithium-ion batteries are able to be recharged hundreds of times, are more stable and tend to have a higher energy density, voltage capacity and lower self-discharge rate than other rechargeable batteries. And a reliable circular recycling process could also reduce unethical mining practices for metals.
So the main issues within the battery is cobalt. So cobalt's mined in the Democratic Republic of Congo, and there's some ethical issues about the mining and where it comes from and its processing, and then that goes into these batteries. And so it's got a long and tortuous journey through some quite challenging processes. We've also got manganese and nickel, which are slightly more readily available but still need to be mined.
While elsewhere, researchers are looking at a battery design that could entirely eliminate the need for cobalt and nickel, the Relib team is focused on working out the most efficient, green and cost-effective way of disassembling the variety of battery packs currently made. Dr. Rob Somerville is about to demonstrate one of the noisiest methods.
So this is where we keep the safety chamber. I call it the T-Rex enclosure. Dan calls it the Velociraptor enclosure. I think T-Rex enclosure is a better name.
But hang on, who's the boss?
Opinions vary.
Oh, righto. Well, we'll call it T-Rex for now, Rob.
Thank you.
Wow.
So this is the safety chamber. It's got some nice lightweight doors.
Ooh, bright and shiny.
Yes, it's all very nice.
So what happens in here?
So this is where we do our more exciting battery experiments. So this chamber is designed to contain a battery fire. In the event that something exciting happens, we can just shut the doors and go for lunch, and we don't need...
When you say exciting, you mean dangerous, basically?
Yes.
Yes. Okay, good.
Yes.
You're probably expecting something quite high-tech, but it's far more agricultural. Rob's about to put a battery into a shredder. So shredding, is that one of the main ways of recycling at the moment?
Yes. Shredding and separating out the shredded components is one of the most effective ways of recycling batteries at the moment. Other alternatives are to put the entire battery into a furnace and where you only get out some of the more valuable components, but you don't recycle the entire battery. I have an enormous bias, but I think that shredding is the way to go.
Only because it makes a lot of noise, obviously.
Yes, it's
and you
lots of
get to
fun.
wear the fancy suit.
Yes.
Let's do it. The UK currently sends all its batteries to Belgium to be recycled in a furnace, which only recovers about 70% of the metals. Some come out as an alloy, but the lithium is lost. While shredding is a common way to recycle, Rob and the team are experimenting with cleaner new generation chemicals, using as little effort and energy as possible. Using their technologies, they can return over 90% of materials with fewer CO2 emissions and at a lower cost. So they'll put this battery through a few times, but obviously in a recycling plant, it'll hopefully go through several different shredders, rather than somebody like Rob standing there just feeding it in. A short while later, Rob's changed from spacesuit to daywear to show me the final product. Done!
Done. So this is the battery after it's been through our shredder a few times.
So what happens with this next?
I'll be separating off the plastics, and then I will be focusing on trying to get the valuable active material, which is the black coating, off the aluminium and copper foils.
So will you do that chemically?
It will be a chemical process eventually, but before you put it through a chemical process, you want to remove as much as you can, so you put as pure a material as possible through your chemical separation process, because the chemicals are expensive, and if you can use cheaper methods to purify your materials before you use expensive chemicals, it makes your process much more cost effective.
But before you can shred batteries, you need to extract them from the pack. The Relib team not only wants to recycle the batteries, it wants to recycle everything with help from what they call collaborative robots. Dr. Ali Reza Rastagar-Panna leads the team. So what are we looking at here?
We have a Nissan Leaf battery pack, model 2012, and as you can see here, we have different components embedded inside this battery pack. So we have 3 stack of modules. We call these battery modules, and inside these battery modules, depending on the type and the model, we have lithium-ion cells. For example, for Nissan Leaf 2012, we have 4 cells embedded inside the module.
With so many different batteries on the market, trying to disassemble them all in one plant would be inefficient and labour-intensive. Automating the process would improve safety and speed, but without eyes or hands, these robots must be programmed and guided to use different kinds of sensors to judge size, distance and force.
And it was manually disassembled. However, what we are doing here is a kind of reverse engineering. We are trying actually to understand what's the best sort of action required for the robots in order to tackle the problems and disassemble the components.
Ali and his team are also trying to figure out the level of autonomy required by the robots, which depends on the complexity of the task.
And now we move to another robotic cell that we have with other collaborative robots here. We call them Frank robot arms. And there is a cutter attached on the right arm, and there is a vision sensor camera attached on the wrist with a vacuum suction gripper again here. But it's very tricky to open the top case without damaging the lithium-ion cells, because we want to know if we can reuse them or is end of the life of these lithium-ion cells and it should be sent to the shredder for recycling purposes.
With a greater understanding of how batteries are put together, the Relib team can inform manufacturers on the products and binders they could use to make recycling more efficient in future.
We need to set a recycling process that can cope with this evolution, can cope with the innovation in the battery and within the car sectors, and allow us to recover the materials. We don't want recycling to restrict and hamper innovation on batteries, but by the same token, we need batteries that are recyclable and designed for recycling and designed for remanufacture.
Car and battery manufacturers are also working on recycling solutions. In China and Korea, where the bulk of the world's batteries are made, recycling solutions are being explored. Volkswagen has opened its first battery recycling plant in Germany, while Nissan is also working on Second Life battery initiatives and has been authorised to use its Leaf batteries in stationary energy storage. In Birmingham, improving the shredding process is not the only solution they're working on. Once again, the Nissan Leaf cell is taking centre stage, and it looks a bit like a book when you open it up.
So here's one I ripped earlier. You can see that it's got a little bit of copper shining through underneath the graphite. So that's the anode there. Separating the anode from the cathode is a separator, which is plastic, and it is designed to melt at high temperatures, and it's porous to electrolyte, and it stops the anode and the cathode from coming in electrical contact. Because if that happens, then you'll get a short circuit, and you'll have a very bad day. So this is the cathode, and it is aluminium, which is coated by your mixed metal oxide. In this case, it's nickel, manganese, and cobalt oxide. And you've got another separator and another anode. And it's a stack of this all the way down.
All right, so once you've done that, and you've separated all these bits out, what happens then?
After that, we'll want to separate the active material, so the graphite or the mixed metal oxide, from the copper or the aluminium. That way we can recover the aluminium as aluminium metal, as opposed to turning it into a slag and then losing all the embedded energy cost in trying to get the aluminium back as a metal. If we can also increase the purity, it will make our processes much more cost effective. And being able to separate the materials like this will make the recycling process more effective for batteries which have less value in them. Batteries like these, which contain nickel and cobalt, are quite nice and valuable because of the nickel cobalt content. But for batteries such as lithium iron phosphate, iron and phosphorus aren't particularly expensive. So being able to separate out the components first to be able to get the lithium iron phosphate and your aluminium in nice, clean, separate streams will make the recycling process much more effective.
And that's where a new pioneering technique being worked on by Relib partners at the University of Leicester could be a recycling game changer.
So what we're looking at here as part of the project is to separate the batteries into anodes and cathodes. So these different active materials, the graphite in the anode and the nickel manganese oxides in the cathode, to prevent the mixing as we get with shredding. And so this is an anode, so it's mounted onto copper and it's made of graphite and binder. So this system in the middle is sending ultrasound waves through the assembly, and as you can see, coming out the other end is a pretty clean current collector.
That is amazing. Look at that.
And so this is what happens when the waves interact with the surface. You can see the vibrations that are caused breaking up the surface, and that eruption distributes the material off the current collector and into the solution. So the ultrasound is passing through a solution of organic solvents, and it's vibrating the current collector and the active material, and the active material is falling off with gravity. So there's nothing other than sound waves causing this delamination.
So when you look at what the shredder does and pulls everything apart, you could just have multiple baths with all these waves coming through and just coming out clean every single time.
Absolutely, and this is what would allow the recycling industry to extract the current collector metal and this active material in one easy step and really change how we can process and reprocess this material.
And the purity, I mean, it's completely pure, isn't it?
It's completely pure as it comes out of the battery. So we may need to do some repurification, but nothing compared to other methods.
So this new method you've come up with, this isn't anywhere else?
This is nowhere else. This is a game-changing technology that allows us to recover the material in one step very quickly.
But Dan's team won't be stopping there. They want to inform the industry by working on how to redesign batteries and optimise manufacturing techniques to make them not only more efficient, but also more efficient to recycle.
So one of the key areas we need support from governments and government agencies to make recycling mandatory. And we need to incentivise recycling, so this will allow the industry to take off. We then need a cost-effective process that allows value to be added through recycling.
So what's the big plan here? To have your own manufacturing plant which will recycle and then make brand new batteries?
So at the university and in the Faraday project, we're going to set up and show this technology is possible. We're going to build a demonstrator site out at Tyseley here in Birmingham, and then we're going to be able to license and demonstrate the technology that as more electric vehicles come to their end of life, that other companies will take up this technology and recycle the batteries fully.
With millions of hybrid and EV batteries to be retired in the next decade, there's an urgent need to solve the recycling problem. Because, as we've already said, the world can ill afford to replace one kind of pollution with another.